In this video, I'm going to show you how to solve equations that require one step in order to find a missing variable, okay? So for example, maybe you're posed with the question, 23 plus, or equals, equals 8 plus v, okay? So you're given the question 23 equals 8 plus v, and it probably will say something like solve or solve the equation, okay? And it's, you have to solve for whatever variable it is that they give you. So in this case, it's our v, okay? It might be x, it might be a. And there's a process that we use to figure out what this v means, okay? When I'm talking to my students, I say, okay, well, think about what v has to be in order for that number plus 8 to equal 23, okay? That's the thing I want you to think about. What plus that number, okay, is going to give you 23, all right? So let's think about that, right? If I'm thinking about 8 and I'm thinking, okay, if I want to go from 8 to that number, so if I, let's say draw a line here so we can see what that looks like. Let's use a number line. If I have a number and I'm starting at 8, right? I'm starting at 8 here, 8. And then I want to get to 23. What's the space between 23 and 8, right? Well, 8, 9 is 1, right? That's 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. How many spaces do we have to go, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? 8 plus this distance from here to here, right, is a distance of 15. Okay, it's 15. And that's how far you have to travel from 8 to 23 in order to get there, right? So we know that v is going to eventually be 15. But how do we prove that, right? We've done it this way, but this is a rather slow process. It's a little bit annoying, and it starts to become difficult when we're trying to use bigger numbers that have a bigger distance in between them. So what we can do is we're going to try to essentially manipulate these numbers here. We're going to try to use them to our advantage and move them around so that v is the only number or only variable on one side of the equation, and then everything else is on the left. Okay, in this case, v is on the right, and then everything else is going to be on the left. Now, how do you get v by itself? Okay, how do you get v by itself? Well, in this case, right, we've got this 8 that's being added to v. Okay, so we have right here, we have a positive 8, and that's being added to v. So if I want to get that 8 to the other side, I have to subtract an 8. So if I want to get rid of the 8, I have to subtract an 8. Now here's the problem, okay? You can't just take away 8s. Okay, you can't just take away a number from that side. It would change the equation because then you've taken out 8 pieces. In order for this thing to stay balanced, you have to do the same thing to both sides. So in order for this to work out, I have to do 8 minus 8 on this side, and then I have to do 23 minus 8 on the other, right? Another way of thinking about it is we know that eventually this v is going to be 15. Okay, so how do I get 23 to be 15? Well, I take away 8. Okay, so down here, I'm going to get a 0. Right here, I'm going to get a 0 because 8 minus 8 just cancels out. And I'm left with this v. I'm left with v. And that's going to be equal to 23 minus 8, which we know to be 15. Okay, and this 0 obviously doesn't do anything, so we can rewrite that as 15 equals just plain old v. And so we have proven using algebra that 15, oh dear, I'll just draw that, that this here, right, we know to be just 15. V is equal to 15. Okay. Let's look at maybe another one. Let's say you were going to do something and you had something like, let's say you had x. Let's say you had x minus 5. You had x minus 5 is equal to, let's say 17. Okay. So you had x minus 5. X is a number. You're subtracting 5 from that number, and it's going to give you 17. Now, if you're thinking logically, right, what number minus 5 gives you 17? Well, I can think of that one. That one's 22, right? But again, how do we prove that? So what we have to do is we need to get this x over here by itself on the left, and then have every other number go to the right-hand side. Now, this is different from what we see in the first problem. We had 8 as a positive number. Here we've got a negative 5. If I want to get rid of that negative 5, all I have to do is add 5. I want to get that 5 to 0. Okay. So I'm going to add 5 here. And again, I can't just add random 5s in. I have to do the same thing to both sides. So I'm going to add this 5 on the right-hand side as well. Now what happens over here is that negative 5 and 5 will just cancel out, and I'm left with just x because this will go to 0. 0 doesn't really affect our equation anymore. We can let that go. And then 17 plus 5 we know to be 22. Okay, so we've again proven that x is equal to 22. Okay. Let's try one that has multiplication and division. Okay, so we're going to do 2 more problems. Let's say that I had the number, let's say that we had 16, right? Let's say we started with 16 and we said that we had a variable. Oh, let's do a, why not? So let's do 4a. Okay, 16 is equal to 4a, and I'd like to know what a is. Again, what do we know when multiplied by 4 gets us 16? So if we multiplied this a by 4, what number would it have to be in order for that to equal 16? Well, we know that 4 squared, or 4 times 4, gives us 16. So we're looking for a way to transform this a into a 4, or have at least it equal 4 when we take it and make it by itself on the right-hand side. But I'm not doing addition or subtraction. So if I subtract a 4, right? If I subtract a 4 from here, if I subtract 4 here and I subtract 4 here, that doesn't do anything because I'm going to balance it on either side, but I'm stuck with this random 4 here. It doesn't cancel out multiplication, so we can't do that. But what we can do is we can pull out this 4 factor and divide out a 4 on both sides. We're going to do the opposite of whatever we see here. So 4 divided by 4 over here, and then 16 divided by 4 on the left-hand side. And if we simplify this, 4 over 4 simplifies down to 1. Right? So I'm going to have a 1 here. And then 16 divided by 4, we know to be 4. It's actually 1a. And then we know that 16 divided by 4 gives us 4. Now this 1, right, 1 times a, if you do anything times 1, it's going to be itself. So we can actually kind of ignore that 1, and we can write this as 4 is equal to just a, okay? So we have 4 is equal to a, and if we plug this back in, we can check our work, right? You have 4, you plug that in for a, 4 times 4 gives us 16, we're good to go, right? We can check our work that way. Last thing, let's try one that has division in it as a starting point rather than subtraction. Why don't we do that negative 9? Negative 9 is equal to, let's say b divided by 9. Okay, so we've got negative 9 equals b divided by 9, and we'd like to figure out what b is. Now, so far, we have seen a pattern through the last few problems, right? I want you to take a second and try to figure this problem out on your own. So assuming that you have, in the last 3 problems, right, when I had an addition symbol, I had to subtract out this 8 in order for v to be by itself. Here, I had a negative symbol or a -5 to start, so I had to add a 5 in to solve my equation. Over here, we started with multiplication. We had to divide in order to get our answer. So we're going to do the same, use the same idea here for this problem, okay? So what you should do is you should think about if I see, oh, that's a bad drawing. I apologize. If you see addition when you start out and you want to get something by itself, you should subtract. If you see subtraction, you should be adding. If you see multiplication, okay, if you see multiplication, you should divide. And if you see division, you should multiply. Okay? So when this is where you start, or this is what you see, and then this is what you do. Okay? This is what you see, and this is what you do. All right? Now, in this case, we have b divided by 9. Let's make sure that actually looks like a 9. Okay? B divided by 9 gives us -9. I need to know when I divide it by 9, what gives me 9? We're going to kind of use the same principle here with this square, right? I know that 9 times 9 gives me 81, right? And I also see that this is division, so I have to multiply, right, by something in order to get b by itself. Well, b is being divided by 9, so I'm actually going to have to multiply by 9 on both sides. Okay. And if we rewrite this, right, we have 9 times -9, a negative times a positive gives us a negative, and 9 times 9 gives us 81. And then since we're multiplying by 9, this is actually the same thing as multiplying by 9 over 1. So I get 9 times b over just 9 times 1, which is 9. And then we're kind of seeing the same thing we had up here, right? You take that 9 and you divide it by 9, so you'll end up with -81 is equal to 1 times b, which we can rewrite just as -81 is equal to b. Okay. So again, when you're solving equations like this, one-step equations, look at whatever it is that you are starting with. If you're starting with multiplication, then you should divide. If you're starting with addition, you should subtract, and then you follow through. You can always recheck your answer. Plug in that number, right? So if I'm confused about this last problem we did, if I'm not sure if -81 is the right answer, plug in -81, right? Plug in -81. Is -81 divided by 9 the same thing as -9? And yes, it is, right? You do -81 divided by a +9. You break that up into 9 pieces of -9, right? So you do have the right answer. You got to check your work.